All right, hey, stats. If you are a TI-84 user, this is the video for you. It was hopefully in the TI-84 video folder. What we're going to look at today is how do we do some of the stuff with scatter plots and two variable data that we're talking about here in chapter 3. And so we're going to look at a couple of pieces of the puzzle today. Hopefully this is enough to get you through chapter 3. All right, and this should be the very familiar TI-84 screen that you're used to seeing. So we've got, again, the stat button that we're going to be using. And when I go to the stat button, I have a set of data I have inputted here. And this is the data that I said on the last video from page 145 I'm going to use. So on the left side, you have the weight of the hikers. And on the right-hand side, you have the weight of their backpacks. And you can see if I scroll up here, I have all the data inputted into two lists. And this is paired data. So it's important to remember that the 26-pound that I'm highlighting right here goes with that 120-pound hiker. And so we're always going to keep these lists together as I entered them so that everything matches up perfectly. That's really important when you have ordered pairs of data. So the 187-pound person has a 30-pound pack, the 109-pound person a 26-pound pack, and so on. So the first thing I want to show you is how to do the scatter plot. And in the stat plot menu, like before, okay, it's up here, the stat plot, we're gonna hit blue and then go into stat plot. You know, I have it still, it's still on the normal probability plot from last chapter. So all I have to do here is change it to the picture that looks like a scatter plot, and that's this guy right here. So I'll select that. And now it'll ask me, okay, which list is my explanatory variable? That goes in the X list, and my response variable goes in the Y list. Well, if you remember from the previous video, the idea here was to talk about how much does a person's backpack weigh as it depends on how much they weigh. In other words, the weight of the backpack is responding to the weight of the person. So the weight of the person is our explanatory variable. The weight of the backpack is our response variable. So I have it set up pretty much correctly right here. And that's all there is to it. When I go to my graph, you know, I won't see anything right now because it's zoomed to the previous data. So I'll go to zoom and I'll go down here to choice number 9, which is zoom stat. And you'll see those dots just nicely laid out there. And again, thinking back to the first video, you know, we would say, oh, look, there's a positive correlation here because it does tend to be going up as we go across. Would we say it's linear? Probably we would say it's linear. We don't have any reason to not believe it's linear. You know, it just depends on this outlier here. If that person wasn't there, then it looks very much linear. And so that was the outlier person we had identified in the previous video as well. So that's the scatter plot. To do the other computation here, that correlation coefficient, we're going to have to do a couple of things here. With the 84, you got a unique calculator here, guys. They come shipped from the factory with something called the diagnostics turned off. I don't know why the diagnostics are off when you get it, but they are. So if you'll notice down on your 0 key, you'll see the word catalog. Okay, so let's go 0 and then to the catalog. And I'm going to scroll down until I see something that says diagnostics on. Okay, now I'm actually going to cheat. I'm going to hit the D button. It'll take me to the D's. And then I'll scroll down to diagnostics on. And you see there, diagnostic on. I'm going to hit enter. It'll bring it to the main screen, and I hit enter again, and it says done. And I have no idea why the diagnostics don't come turned on. It just boggles my mind. But there you go. It's how they ship it. So in statistics, when we go to make a graph, a linear graph, couple of things that I need to first make you aware of. So let me jump over to a whiteboard screen for you. The equation of a line. Like if I were in algebra class, I said, hey, what's the equation of the line? I think most of you would say y equals mx plus b, where m is the slope of our line and b is our y-intercept. Okay, and for algebra and everything, that works great. That's our algebra equation. The folks in statistics, well, they wanted to be a little different, I guess. Okay. The first thing that I'm going to let you know is that a lot of times this is called a prediction equation. Prediction equation. Oh my, that's not writing very smoothly, is it? Let's try that again. There we go. And so when we write it in statistics, we'll often put a little hat on the y. So that is actually literally read y hat. Okay. And the equation is usually written like this: a plus bx. I know, it's super frustrating. Okay, why they didn't get the memo on the mx plus b thing is weird. All they did was rename the coefficient and the constant with a different letter. Okay, it's still the same thing. Oops, didn't mean to do that. The still a is that's just the y-intercept. In this case, the slope, the number in front of x is the slope. All that's the same. Just prepare yourself, because as we work our way through, our prediction equations will usually be written with the response variable with a hat on it equal to a plus b times whatever the explanatory variable is. So that's our response variable right there, and x right in there is the explanatory variable. I forgot the t. There we go. Explanatory variable. All right. So now that we have the idea of a statistics prediction equation, let me show you how to make that on your calculator, because that's part of the stuff that you're going to need for our assignment in the coming weeks. So let me go back over to my calculator here. Oops. And so what we're going to do is we're going to have the calculator tell us what would A and B equal for this equation. So what I'm going to do is I'm going to go to Stat menu again. Okay, so we're familiar with this menu. Now I'm going to go over to the Calculate menu right here. And look at choice number 4. It says LinReg. That stands for linear regression. And it's AX plus B, right? But I said it was A plus BX, right? Yes, I did. Keep scrolling. There you go. Choice number 8, linear regression, A plus BX. That's the one you want. Okay. Now remember, my X list, my explanatory list was list 1. I'm not sure why it says L5 right there. I'll just make that quick change. X list is list 1, Y list is list 2. Now, this is part of the video where you're probably gonna have to pause and rewind it a couple of times, because I want to have it save the equation for me. And you see this at command line here, store regression equation, or it says store reg EQ, but that's short for storing the regression equation. We want to get it to say Y1 right there, but it's not as simple as typing in the letters Y1. Okay, so here we go. Let me show you what we're going to do, and feel free to pause and rewind as much as you need. On your keyboard down here, you're going to see the Vars button. See right there? We've used the distributions button. Now we're going to use the Vars. Okay, I'm going to push that, and look what the menu did. Okay. Now I'm going to go over to YVars. And then I'm going to go to function. And now I can enter Y1 by just pressing enter. Okay, now if you need to, rewind the video, go back through that. I know it's a lot of keystrokes to get there. But as soon as you hit that Vars button, make sure you go over to the YVars menu and then to function, and you'll find that. And I'll show you why we did that here in just a second. So I'm going to go ahead and have it calculate that. And look, it tells me that the intercept, the y-intercept, is 16.26, 265. Let's say it's 16.265, and the slope, B, is 0.0908. And then the bottom line, R value, is 0.794, let's say 7947. Okay, what the R squared is, okay, that's for next week. Okay, that's called the coefficient of determination. Now, if you're watching this and you're in week 11, okay, then you already have learned what R squared is. But if you're watching this and you're still in week 10, we haven't talked about R squared yet. You'll just need to remember that this is how you find it. Okay, now let me show you why I had it store the regression equation to y1. You see the y equals button? If we push that button, you'll see y1 has the equation that we just generated. Okay, it uses all the decimals, but there it is. Okay, and the reason the equal sign is highlighted here over on the left by y1, right here, that's because it's going to graph this equation. So what I'm going to do is I'm going to go back to the graph and you'll see our data, and now we have our regression line nicely plotted through our data. And you can see, oh yeah, that really does look pretty linear. Those last two dots out on the end, right out here, we definitely have the potential to have some outliers out here. Again, we don't have anything like Tukey's equations to help us define that. Next week, if you're watching this in week 10, we are going to help you determine whether or not we have outliers in our data set. And it'll be coming back to this exact same part of your calculator. So there you have it, guys. That's how you do everything on the Texas Instrument TI-84 for Chapter 3. If you need to, pause, rewind, go back through this again. If you have that data set, remember, it's on page 145 in your book, so you can enter it in and try it on your own. And see if you can generate the same regression model that I did. All right, guys, thanks so much.